Okay, so this is the Hermite equation, and lambda is the constant, yeah? Um, so we will find the first four terms in each of the two solutions about x equals 0, so we will expand about x equals 0. So we will assume solutions of the form assume solutions of the form y equals summation from n equals 0 to infinity, always the case, yeah? A of n x to the n. We will find first derivative, second derivative, plug them into the differential equation, and then try to establish a recurrent, either figure out the coefficients or establish a recurrence relationship between the coefficients. Okay? So you should be able to do this one. Let's get started. So y prime an times n x to the n minus 1. And now we lose one term in the process. So now this starts at n equals 1. And likewise, y double prime will be an times n times n minus 1 times x to the n minus 2. And now this starts at n equals 2 to infinity. And now we take those and we plug them into the original differential equation. So substitute into the differential equation. So we get y double prime of n times n minus 1 times a of n x to the n minus 2 plus or minus 2x times y prime. So I will go ahead and immediately multiply the x by x to the n minus 1. So this becomes minus 2 summation n a of n x to the n minus 1 times x becomes x to the n, because n minus 1 plus 1 is just n. And this is starting from n equals 1 to infinity. Plus lambda times y, which is the original. So lambda a of n x to the n from n equals 0 to infinity, and we have to set this equal to 0. Okay, so we can see that all these three series now are starting at different places. So we need to make them, first unify them, and then make them start at the same place. So what we'll do on the first one is we're going to say replace k with n minus 2. So that means this first one now starts at k. You know how to start this one or no? You assume solutions of the form a n x to the n. You take derivatives, you plug them back in. You're going to have this on the test, so you should know how to do it. So this is k equals 0, because, you know, now n minus 2 is that. So that means n minus 2 starts at 0. And n, I will replace it with k plus 2. So this becomes k plus 2 times k plus 1 times a of n, which is a of k plus 2 times x to the k, minus 2. Now, here I will replace, I will actually do no replacement here. So everything will remain as is. So this is 2n a of n x to the n, because this already has x to the n. Or I'll just replace n with k. How's that? Just to make everything the same index. So ak, and let's call this x to the k. And this starts from k equals 1 to infinity. Okay, and here, same thing. So n is k, so lambda a of k, x to the k, from k equals 0 to infinity. Now, since the first one starts at 0 and the last one starts at 0, I will absorb the first term from both of these so that everybody starts at 1. And then I can merge them under the same summation. So if k is 0, I would get 2a2, x to the 0 is just 1. And then from the last one, I'll also absorb the 0. So this will be lambda a0. And then what I have left, the first summation now starts from k equals 1 to infinity of k plus 2 times k plus 1, a of k plus 2, x to the k, plus or minus, the second summation is minus 2k a of k, x to the k, also starting at 1 to infinity, and the third summation also starting at 1, infinity, lambda a of k, x to the k, and this is equal 0. Okay. Okay, now that all of them have x to the k and all of them starting at k equals 1, I could factor out. So first bring these two constants down. So 2a2 minus lambda a0 plus k equals 1 to infinity. I could factor out x to the k. So we have left k plus 2 times k plus 1 times a of k plus 2 minus 2k plus lambda a of k. I absorbed the second 2 into the same coefficient a of k because they both have a of k. Okay. If you get stuck, then ask me. Don't be stuck too long. And that's equal 0. And now I'm at a point where I could set the coefficients equal 0. So now we can say, okay, this here is equal to 0 because the whole series has to be 0, right? And this here can equal 0. So 2a2 minus lambda a0 equals 0. You follow? Or, which makes a0 be 2 over lambda A2. Okay, so that's the first relationship. And the second one is k plus 2 times k plus 1 times a of k plus 2 has to equal, this whole thing has to be 0, so that means this has to equal minus 2k plus lambda a of k. Which means what? Which means a of k plus 2 has to equal minus 2k plus lambda over k plus 2 times k plus 1 a of k. Okay. Meaning what? Meaning when k is 0, and that's true for k equal 0 or 1, two, 3, all the way. Okay. So let's go ahead and start plugging in some things here. Because we are looking for the first 4 terms in each of the 2 solutions. So let's see. Questions? Where are you so far? Let me check on you. Yeah.
Put it in terms of that, and now we have to shift the index on a couple of them.
Yeah. So did you find the derivatives?
Yeah.
Why is this x minus 1?
Oh, because it was multiplied by y prime was multiplied by x minus 1 squared.
Why x minus 1?
Because it's what it was multiplied by.
No. We're doing 21.
Oh, crap.
We're doing 21.
Oops.
Okay. So when k is 1, we get A2, A3.
Was 21 on the homework?
Yes. Your homework was 21.
Not 19?
No, not 19.
Oh, oops.
A3 minus 2. Well, it was circled from last semester. 3 times 2 is 6. A1. Okay. And if k is 2, we would get A4 equals minus 4 plus lambda over 4 times 3 is 12. A2. But what's A2? A2 is lambda A0 from here over 2. So this becomes lambda 12 times A2, which is lambda A0 over 2. Okay, so that's A4. And then what's K3? And we get A5 equals minus 6 plus lambda over, this is 5 times 4. Let's just leave it as 5 times 4 so we can better find a relationship, yeah? 4 times 3, and here it was 3 times 2. Okay, and then so here times A3, and A3 is nothing but this one here. So minus 2 plus lambda over 3 times 2 A1. Alrighty. Um, and if k is 4, then we will get A5, A6 to equal minus 2 times 4 is minus 8 plus lambda over 6 times 5 times AK, and AK is A4, and A4 is just all that, minus 4 minus lambda over 12 times lambda over 2A0. So we can express all the coefficients in terms of A1 and A0. That's why we're going to get two distinct, two unique solutions. A1, A0, Y1 plus A1, Y2. So K5, this will give us A7 to equal minus 10 plus lambda 10 times times 6, or oops, wait, I forgot the let's actually move this term here. minus 4 minus lambda over 12. Where did the 12 come from? Oh, that's 4 times 3. Let's write this as 4 times 3 times lambda over 2a0. And we could keep on going as such. Let me see if it's needed to go further. 1, 2, 3, 4, 5, 6. I think that's enough terms for us to establish a general correspondence. Where are we?
Fix the thing. No. Did it say that gamma was a
Constant.
constant?
Hang on. Okay. So that pretty much establishes a connection. So then we get, so now we're going to take all this and plug it into the solution, which is a0 plus a1x plus a2x squared plus a3x cubed plus a4x to the 4, etc. all the way. So let's get back to blue here. So a of 0, we will leave it a of 0. And 2, 1. Plus now the second term that has a of 0 is 2, so that would be the x squared. Yeah. So that's going to be a0, that's the a4. a2. Oh, that's lambda a0 over 2. So that's just lambda over 2. Yeah. Fair enough. Okay, so got it done. We assumed solutions for this Hermite polynomial equation in the form of y equals a n next to the m. We found the derivatives y prime and y double prime, and that shortened the series by 1 because every time you take the derivative of a constant you get 0. We substituted into the differential equation, and then what we did is we made them all start at the same place, so k equals 1, by absorbing 2 k equals 0 from the first series on the left and k equals 0 from the third series on the right. So we made them x to the k, and we factored out all the coefficients. So there's an x to the k here, of course. We set all the coefficients equal 0. We find that a0 was 2 over lambda a2. And then we found the recursive relationship between ak of 2 and a of k. And then we started plugging in numbers, k equals 1, k equals 2, k equals 3, all the way down. One moment here. This is minus. How come we have oh, this is plus lambda a0. Yeah, this is plus when x is 0, this is n is 1, n is 1 and n is 2. Yeah, this is a plus here. So this becomes a plus, which makes this a plus, which puts a minus sign here ahead of a of 0. Okay, so then that makes this a minus, and that makes this a minus, and that makes this a minus. Okay, fair enough. Questions on that? And this here switches. there's a minus sign here, and minus sign. Okay, so lambda over 2. Okay, plus. So now the third one that has a 0 is the x to the 4. Right? Hold on, let's fix this here really quick. So this is lambda 2, this is minus lambda. So this is minus lambda, and this is plus 2 minus lambda, and this is plus 4 minus lambda, a2, and a2 is just minus, so this makes this 4 minus lambda, and this here, let's fix that, 6 minus lambda, and then 2 minus lambda, okay, and then a6 is minus 8, 8 minus lambda, 4 minus lambda over 12 minus lambda over 2, okay. And for 5, this is um, 10 minus lambda, and minus lambda. What's this? Sign mistake here, dragged everything down. And this is 2 minus lambda, a1, okay, good. And then down here, this became 12 minus lambda, and this is 8 minus lambda, and this is 4 minus lambda, and this is minus lambda over 2, okay, fair enough. And then this is 4, and this is 10 lambda, minus lambda, and this is minus lambda over 2. Okay, fair enough. So we got, so this guy needs here to be adjusted. So minus lambda over 2, fair enough. So that's the, which term? That's the A2. So that just means this is the x squared term. So we have x squared. Plus, now the second term that has A0 is the to the fourth, which is so what's a to the fourth? A to the fourth is lambda times lambda minus 4, yep, over 4 factorial, yeah. Okay, good. So this is adding up. So lambda times lambda minus 4 over 4 factorial. Why 4 factorial? Because 12 times 2 is 24 and 4 factorial is 24. If you get confused, you can always rewrite this as 3 times 4, and then you can see it that it's 2 times 3 times 4, so that's 4 factorial. Okay, so that's x to the 4 plus, now the second place where A0 appears is on k equals 6. Or no, on k equals 4. Okay, we already said that. No, k equals 4 is the second place it appears. Yeah. And what that gets you is it gets you a of 6, which is lambda times lambda minus 4 times lambda minus 8. Yep, over 6 factorial, precisely the case. So that's good that the answers here are matching. So we get lambda times lambda minus 4 times lambda minus 8 all over 6 factorial. And this is x to the 6 because this is happening on a6th. Plus dot dot dot. Plus dot dot dot. Okay. Plus, now we will go and hunt the terms that has a 1 in them. Where are you, Ben? You need help there? Let me try to...
trying to figure out how to separate out, like, because this one has a lambda, but that one, the other two don't.
Doesn't matter. Yeah, they're not going to all have lambda. It's going to be separate. Because a lambda is like a number.
Yeah.
Has nothing to do with lambda. The
Yeah.
challenge is to unify the power of x to all be x to the k or x to the n. And the second challenge is to make these series here start in the same place so you can unify them under the same series. And thereby set the coefficients, in this case equal to 0, so you can solve for them.
Okay.
Already? So look, they start at different places, yeah?
Yeah.
Okay, now when you multiply this x here, you get x to the n.
Yeah.
And this is x to the n minus 2. So you need to shift the index here and call n minus 2k. So that this becomes x to the k.
Right. Right.
So that's what you have to do now.
Yeah. All right.
You understand?
Oh, so I get it then. So 2x.
So you need to call this k, and then whatever there is an n, you replace it with k plus 2 here, so that this becomes x to the k,
Yeah.
just like the rest of them.
Yeah. Oh, I get it. I can call n times 2x gamma and n minus 1, or n times n minus 1 would be 2x. So we got n times n minus 1, which would be n times 2x. And then we have n times.
No, Ben, just do the step I'm telling you. Call that, unify all the x's to equal k.
All right.
Look here. Let me show you the step. So I called k to be n minus 2. What that did is it did two things. First, it made x to the n minus 2 x to the k. And the other thing it did, since this is n equals 2, and now k is n minus 2, that means this is starting at k equals 0. So they're all going to be starting at the same place soon.
All right.
Already?
Yeah.
And then the next step, watch. After you do that substitution, you leave those k as is. You run into another issue, which is the middle one starts at 1, and the ones on the sides start at 0.
Yeah.
So then what do? Then you absorb the k equals 0 from this and this. And then they all start at k equals 1. Then you can factor them together under the same series. Once you get to the point where A, they all start at k equals 1, B, they're all x to the k, so you can factor x to the k out, so that this whole thing becomes the coefficient. Okay?
All right.
We have issues? Or no?
What do you do about the lambda
The lambda is a number, nothing. I leave it in my numbers. I'm not concerned about lambda. That's not the...
Wouldn't one of the series have lambda and one not? Or two?
Doesn't matter. Yeah, I'm getting my coefficients as functions of lambda. It's fine. And that's matching the answer.
Oh.
Lambda will be in your answer.
Yeah. All right. Yeah. There's coefficients.
Lambda will be in your answer, yeah? Let me take a rest from... Any questions so far? So far making sense? So now we'll gather the A1 terms. So the first place where we have A1 is clearly oh no. Yeah. So it's just A1x, the first one. Now the second place is the x cubed. That's when it's 3. So that yeah, lambda minus 2 over 3 factorial, perfection. Lambda minus 2, 3 factorial x cubed. And the third place is lambda minus 2, lambda minus 6 over 5 factorial, perfection. And this is just x to the 5. Yeah? And then the third place is let me try it here. Lambda minus 2, lambda minus, yeah, over 7 factorial, yeah, perfection. So plus lambda minus 2 times lambda minus 6 times lambda minus 10. And there's a minus sign because we factored out a minus sign from all this. All over 10 factorial, or 7 factorial, times x to the 7. Plus dot dot dot. There we go. So this then is our solutions in the form of y1 equals a0, or y general is a0 times y1 plus a1 times y2. So we've answered the first question. In each of the two solutions, we found the first 4 terms. One, two, three, four. 1, 2, 3, 4.